spin-half systems. Once again, before proceeding the general discussion of observables, we once again consider the spin-half system. So in this time, we will define the operators Sx, Sy and the state eigengets get Xx plus or minus and get Sy plus or minus. So for that, recall the Stern-Gerlach experiment, and where the Sx plus beam is subjected to an apparatus of type SGZ. Here Sx plus beam, it is subjected to SGZ, that is in the Z axis magnetic field is applied in Stern-Gerlach. The beam is split into SZ plus beam and SZ minus beam with equal intensities. So we can say that the probability for the Sx plus state to thrown into get SZ plus or get SZ minus simply half each. So this state is simply represented by get plus or minus, that is the Z component of the spin. So hence we can write the probability as modulus of bra plus get Sx semicolon plus square is equal to 1 by 2. Similarly, modulus of bra minus get Sx plus square is 1 by 2, because we already said that the probability for Sx plus to thrown into plus state is plus state, and അതേപോലെ തന്നെ Sx plus thrown into Sz minus is also half, they are equal, that is why we are taking half here. So from this two equations, which implies modulus of bra plus get Sx plus is equal to modulus of bra minus get Sx plus is equal to 1 by root 2. So we can construct Sx plus get as get Sx plus is 1 by root 2 get plus and 1 by root 2 e raised to I delta 1 get minus, where delta 1 is real, the coefficient of get plus chosen to be real and positive by convention. So Sx plus, as we mentioned, Sx plus and Sx minus are alternative mutually exclusive. So they are orthogonal, that is bra Sx minus and Sx plus is equal to 0. That is bra Sx minus, substituting from equation 1, is equal to 0. That is, to this equation to be orthogonal, the Sx minus should be get Sx minus is equal to 1 by root 2 get plus minus 1 by root 2 e raised to I delta 1 get minus. Okay, so put it as equation number 2. So we constructed Sx plus and Sx minus. Now we want to construct the operator Sx. So we have, if A is an operator, then by inserting or by applying closure property or completeness theorem, we can write operator A as A is equal to summation over A prime, eigenvalue A prime, get A prime, bra A prime, which is equal to summation over A prime. This is the projection operator, so which is denoted by lambda A prime. So we have this equation. So according to this, Sx can be written as Sx is equal to, this is operator Sx, not the eigen get. It is operator Sx is equal to, here the eigenvalue is h cut by 2 here. So h cut by 2, then here the summation over A prime, there are so which is bra Sx plus, sorry, get Sx plus bra Sx plus plus mutually exclusive alternatives are upstate and downstate present. So we have to add this. So we have added the plus state. Now the for the minus state, that is get Sx minus bra Sx minus. So actually this is fun according to the completeness theorem. Anyway, substitute we already found out sx minus and xx plus from 1 and 2. So substituting the values. So get sx minus is h cut by 2 is there. 1 by root 2 get plus 1 by root 2 e raised to I delta 1 get minus into 1 by root 2, that is for bra sx plus 1 by root 2 bra plus 1 by root 2 e raised to minus I delta 1, because get will, when get becomes bra, a complex conjugate appears. So e raised to minus I delta 1 bra minus so here we substituted the value of get sx, then bra sx plus get sx minus bra sx minus from equation 1 and 2. Okay, so expanding this, sx is equal to h cut by 2 is taken outside, then bra sx plus, so we expanded this equation. Now we must be careful in expanding these terms. Here 1 by root 2 and 1 by root 2 are taken outside, so we will get 1 by 2. And in writing this get plus and bra plus, we must write in the order, in that order. It is not the inner product actually. It is get plus bra plus with 1 by 2. Okay. Similarly, get plus and bra minus, and this is get minus bra plus and get minus bra minus. In this order we must expand. Okay, so we got h cut by 2 1 by 2, because 1 by root 2 into 1 by root 2 will becomes 1 by 2. So get plus and bra plus 1 by root 2 e raised to minus I delta 1 is taken outside, and get plus bra minus 1 by 2 e raised to I delta 1. The next operation, get minus and bra plus 1 by 2 into the next term is get minus bra minus 1 by 2 get plus bra plus 1 by 2 e raised to minus I delta 1 get plus bra minus 1 by 2 e raised to I delta 1 get minus bra plus minus 1 by 2 get minus bra minus. So we just expanded these terms with the correct order. Now look at this. So this 1 by 2 get plus bra plus and this minus 1 by 2 get plus bra plus are cancelled. Similarly, this 1 by 2 get minus and bra minus, and this minus 1 by 2 get minus bra minus are cancelled, and the remaining terms are written here, where sx is equal to h cut by 2. The remaining term is 1 by 2 e raised to minus I delta 1 get plus bra minus 1 by 2 e raised to I delta 1 get minus bra plus 1 by 2 e raised to minus I delta 1 get plus bra minus 1 by 2 e raised to I delta 1 get minus bra plus. Here these two are same term, so we can add it. That is 1 by 2 plus 1 by 2 will become 1. That is, these are cancelled. We get e raised to minus I delta 1 ket plus bra minus. Similarly, the other two terms, the remaining two terms are e raised to I delta 1 ket minus and bra plus. So we got the operator Sx. Okay. So this is Sx is equal to h cut by 2 e raised to minus I delta 1 ket plus bra minus plus e raised to I delta 1 ket minus bra plus. Put it as equation number 3, where Sx is Hermitian. So we constructed Sx, which is Hermitian. So a similar argument with the Sx replaced by Sy leads to. Similarly, we can do Sy. So you must write in your notes. So ket Sy plus or minus is 1 by root 2 ket plus or minus 1 by root 2 e raised to I delta 2 ket minus. Put it as equation 4, and Sy is equal to h cut by 2 e raised to minus I delta 2 ket plus bra minus plus e raised to I delta 2 ket minus bra plus. It is equation number 5. You must work out this in your notebook. So now we already tell delta 1 and delta 2 are taken to be real. So we want to find what is delta 1 and delta 2. So choosing delta 1 and delta 2, for that consider a beam of spin half atoms moving in the z direction. So beam is moving in the z direction. It is go through the Stern-Gerlach x, that is in the x direction. Magnetic field is applied. So as the output we get Sx plus beam and Sx minus beam. Okay, and it is again go through Sgy. Okay, so we get the output Sy plus beam and Sy minus beam. So we can say that, so we are considering this process. So the Sx plus beam is the probability for Sx plus beam to thrown into Sy plus or Sy minus is half. Similarly, the Sx minus beam is thrown into Sy plus or Sy minus, that is represented by here, is also half. So from this equation, which implies modulus of bra Sy semicolon plus or minus ket Sx semicolon plus or minus is equal to modulus of bra Sy semicolon plus or minus ket Sx semicolon minus is 1 by root 2. Okay, so it is equation number 6. So which implies invariance of physical system under rotations. That is actually in this apparatus what happened, the Sgx is rotated, whether it is Sx plus or Sx minus, it is rotated into Sy plus or minus or Sy plus or minus is equal. So the physical system under rotation is invariant, which is 1 by root 2. We got the constant value. So substituting equation 1, that is equation 1 is Sx ket Sx plus. So substituting equation 1 and 4 in equation 6. So we will get, here it is bra Sy plus or minus, and here it is the value of ket Sx plus from equation 1. So substituting 1 and 4 in equation 6, we will get it is modulus of 1 by root 2 bra plus or minus 1 by root 2 e raised to minus I delta 2 bra minus then 1 by root 2 ket plus 1 by root 2 e raised to I delta 1 ket minus, that is equal to 1 by root 2. Now we are going to expand this. So again we must be careful here. This 1 by root 2 and 1 by root 2 become 1 by 2. Okay, and this is bra plus and here is ket plus. We must take it in order. So it is inner product bra plus ket plus, and the next one is plus again 1 by root 2 and this 1 by root 2 become 1 by 2, and here is bra plus and here is ket minus and also an e raised to I delta 1. Okay, so and the next term is plus or minus, here the plus or minus, here also 1 by root 2 and 1 by root 2 become 1 by 2, and here is an e raised to minus I delta 2, it is written here e raised to minus I delta 2, then it is bra minus and ket plus, so it is bra minus ket plus, then again plus or minus 1 by root 2 and 1 by root 2 become 1 by 2, then here e raised to minus I delta 2 and e raised to I delta 1 is here, so it is e raised to I into delta 1 minus delta 2 with bra minus and ket minus, that is equal to 1 by 2. So in the next section what happens, this is 1 inner product with the same ket ana, it is 1, so it is 1, so we will get 1 by 2, then plus this is actually 0 because of the orthogonality, so this is 0, the different eigengets are orthogonal, so that is 0, and again plus or minus, here 1 by 2 raised to minus a delta 2, this is also 0, so that term also 0, then plus or minus, here it is 1, so we get this term. So we can write modulus of 1 by 2 plus or minus 1 by 2 e raised to I into delta 1 minus delta 2, it is in modulus, that is equal to 1 by root 2. So taking 1 by 2 outside, we will get 1 by 2 modulus of 1 plus or minus e raised to I into delta 1 minus delta 2 equal to 1 by root 2. So our aim is to find out what is delta 1 and delta 2 for the construction of Sx and Sy. So this is satisfied only if delta 2 minus delta 1 is equal to pi by 2 or minus pi by 2. That is 1 plus e raised to I theta by 2 equal to 1 by root 2. Then that theta must be pi by 2 or minus pi by 2. So delta 2 minus delta 1. Delta 2 minus delta 1 is pi by 2 or minus pi by 2. So thus we see that the matrix elements of Sx and Sy cannot be real. If the Sx matrix elements are real, then Sy matrix element must be purely imaginary and vice versa. So from this we can say the introduction of complex numbers is seen to be an essential feature in quantum mechanics. So it is convenient to take Sx matrix elements to be real. So Sx matrix elements to be real and set delta 1 equal to 0. And if we choose delta 1 equal to pi, then delta 2 minus pi is equal to pi by 2 or minus pi by 2. That is delta 2 must be minus pi by 2 or pi by 2. but delta 2 is equal to pi by 2 is the correct choice that we will verify in third module. Okay. So to summarize, in this section we constructed ket Sx plus or minus, that is equal to 1 by root 2 plus or minus 1 by root 2 ket minus, then ket Sy plus or minus equal to 1 by root 2 ket plus or minus I by root 2 ket minus, and Sx is h cut by 2 ket plus bra minus plus ket minus bra plus, and Sy is equal to h cut by 2 minus I ket plus bra minus plus I into ket minus bra. And we already found out what is Sz. Sz is h cut by 2 ket plus bra plus minus ket minus bra minus. In the previous class we defined non-Hermitian operators S plus and S minus, and it is defined by S plus is equal to h cut ket plus bra minus, and S minus equal to h cut ket minus bra plus. So here S plus is defined as Sx plus Isy, and S minus is equal to Sx minus Isy. The operator x and sy together with the sz are we found out earlier, and we can show that they satisfy the commutation relation, that is commutation bracket SL comma Sj equal to epsilon ijk h cut sk. It is called the commutation bracket. Okay, so this is the commutation bracket, and you can take some arbitrary SL and Sj, then you will get epsilon ijk h cut sk. Epsilon I alla epsilon L, so it is L, or we can write this as I. If this is I, then this also I, Si comma Sj. Okay, that is equal to I into epsilon ijk h cut k, and the anti-commutation relation, anti-commutation bracket SL comma Sj equal to half h cut square delta Lj, where this is commutator and this is anti-commutator, and it is defined by commutation bracket a comma b equal to ab minus ba, and anti-commutation a comma b equal to ab plus ba. Also we define s dot s is equal to s square, where s square is equal to sx square plus sy square plus hz square. We already found out what is sx, sy and sz when we are taking dot product. Actually it is the sx dot sx, that is the ket terms and bra terms becomes 1, then we will get the h cut by 2. So taking the square h cut by 2 square, h cut by 2 square plus h cut by 2 square, so we will get s square equal to 3 by 4 h cut square. And also we can shown that commutation bracket s square comma si is equal to 0. So I am leaving this as an exercise for you.